Today we're going to take a look at imaginary numbers and roots. So a question that I get a lot when we talk about domain being all real numbers is, well, is there such a thing as a fake number? And yes, kind of, they're called imaginary numbers. So we're going to take a look at those today. Our essential question is, what is an imaginary number and how do we perform operations with them? So if you've ever tried to, for example, take the square root of a negative with your calculator, if you haven't done that before, go ahead and pull out your calculator, pause the video, and see what happens. So my guess is that you got something on your screen that said error. Why do we get an error when we try to take the square root of a negative? Well, let's think about what it means to square root something. It's the inverse of a square. So let's say I have 4 squared. Well, 4 times 4 is 16. What if I have negative 4 squared? Negative 4 times negative 4 is positive 16. So when we take the square root of something, we're asking what number, when you multiply it by itself, gives you that value? Well, there's no number when you multiply it by itself that gives you a negative value. So that's why we get an error message. It's not a real number. So how do we fix that problem? We come up with something called imaginary numbers. And I represents the square root of negative 1. It's an imaginary number, it's not real, because you can't take a real number times itself to give you negative 1. So the difference between real numbers and imaginary numbers are real numbers aren't being multiplied by I, and they don't have a square root under a negative. So you'll see some examples there. All right, let's get into some operations with imaginary numbers. The first thing we're going to do is simplify radicals that are negative. We know how to simplify radicals that are positive. There's one additional step to simplifying a radical with a negative, and that is step 1, pull I out. The way that we do that is think about splitting this up as negative 1 times 125. Well, the square root of negative 1 is I. Now we've got the square root of 125, which we can simplify with our normal rules. So if you think about 125 as being 25 times 5, the square root of 25 is 5. We pull that out with the I, and the lone 5 stays under the radical. So let's look at that again. Sorry, I missed the steps. Simplify by finding the perfect square factors. So we looked at that as a square root of 25. 25 is a perfect square factor. And that's our process. So let's look at the second one. We've got the square root of negative 2. So the first thing negative 72. First thing I like to do is pull that I out and make it positive. Now notice there's already a negative sign outside. So when I pull that I out, it becomes negative I. Now I've got a positive value under the radical, and I know what to do with that. So I'm going to start my factor tree. Hopefully most of you recognize this right away is 9 times 8. Now 9 is a perfect square factor, but 8 has a perfect square factor as well. So if you want to go ahead and completely fill out your factor tree, another way to simplify radicals is by finding pairs in your factor tree. So they come out, 3 times 2 comes out, multiplied with your I, and this lone 2 stays under the radical. So when I simplify outside my radical, I'm going to multiply everything all together to get negative 6i times the square root of 2. And the last thing we're going to do with our imaginary numbers is solve equations. First equation, we've got x squared equals negative 81. So we're going to solve the equation by undoing. To cancel my square, I'm going to take the square root. Remember, every time you take the square root, it's plus or minus, because there's 2 options. Negative 9 times negative 9 still gives you a positive 81. That's not quite what we have. But then we simplify, just the way that we did before. Well, the square root of 81 is 9. So the square root of negative 81 is 9i. Because of that imaginary number, or the square root of negative 1. So let's look at that one more time. Oh, sorry, 2 more times. So solving by undoing, I'm going to subtract the 90 from both sides. Divide by 5 to isolate my x squared. And that gives me negative 18. And then take the square root to cancel my square. Sorry, that negative should be on the inside. So when we simplify our square root of negative 18, we pull I out. And then 18 is 9 times 2, so I'm also going to take the square root of 9 and pull that out of the radical as well. In our last example, we are going to subtract 12 from both sides. To cancel my 1/4, I'm going to multiply both sides by 4 and take the square root. So to simplify square root of negative 48, I'm going to pull the I out. And 48 is 16 times 3. So the square root of 16 comes out as well as 4, and our 3 is left over. And your U-Try problems. Please make sure you come to class with these attempted so that we can work on getting your questions answered and not work on the process. Attempt them and come to class, see what you've got and talk to your peers about how to fix any mistakes you may have made, or as a peer coach, if anybody in your group needs your help.